Good afternoon.
Good afternoon. Hi, everyone. We are gathering. We're still gathering. So in 3 minutes, we shall start. So what's your impressions? What impressions did our conference make? So 1 moment, please.
Hello.
Hello, everyone. We start our session, Corpus Technologies, Ontologies, and Computer Lexicography. As a host, I'd like to present you my report. But before starting, I'd like to ask every reporter to adhere to time limits. So for our 4-section reports, you have 6-7 minutes. So you have 6 minutes, okay? So as not to the session overrun. If we are interrupted, you restart this section using the same link. So, any questions? Everything clear? Okay. So let me start our session. Hello, everyone. Do you hear me well? Okay. So my topic is a digital toolkit to develop research potential of explanatory dictionary. And as example, we take Spanish language dictionary. The development to which this report is devoted to belongs to the staff of the researchers, Yevhen Kupriianov, it's me from Kharkiv Polytechnic Institute, and Volodymyr Shyrokov, Iryna Ostapova, and Mykyta Yablochkov from Ukrainian Lingua Information Fund. So, what is my research about? Fundamental explanatory dictionaries of national languages are of primary interest for linguistic experts. The dictionaries of this kind are characterized by a complete, well-structured, and multi-aspect description of language units and not considering not only semantic, but they are good because they give understanding the meanings of language units in varied contexts and their correct use. Now, the linguistic corpora are recognized as the most effective tool to perform linguistic researches in the digital environment. However, the dictionaries that actively use Corpus technologies for their creation and update remain underestimated in regards to their research potential. So, the goal of our research is to describe to highlight important aspects of creating a linguistic tool to extract linguistic information from the text of Spanish language dictionary. And the aspects covered by the report are as follows. The method, which is our research, is based on lexicographic data model, which forms the basis of lexicographic database, and currently available interfaces and their possibilities they have at the present moment. For research, we have selected Spanish language dictionary of the Spanish Royal Academy, and our interest in this dictionary is arisen by the following reasons. First, its international status of the Spanish language, credibility and academic status of the dictionary, and the last reason is other school of lexicography, which differs from other schools such as Ukrainian and English. As a method of our research, as our theoretical basis, is the theory of lexicographic systems developed and proposed by the Ukrainian academician Volodymyr Shyrokov. Lexicographic system is a special information, semiotic and semantic system in which a lexicographic effect or several lexicographic effects are induced. So we consider the dictionary as a lexicographic system of a special type with a set of language units and a set of their descriptions. So on the basis of this theory, we have developed a formal model which reflects a lexicographic structure of the dictionary and defines information elements of the dictionary to be accessed by the user when working with our digital toolkit. When the next stage was parsing of the Spanish dictionary. So we extracted dictionary text, not the whole entitled, but a part of dictionary text from online version of Spanish dictionary. Then we using special software performed marking up of the Spanish text. But before marking or special this text, we made preliminary entry text analysis and entry structure definition. Then the marked text of the dictionary has been converted into a database which can be managed by through the interface named Virtual Lexicographic Laboratory, or VLL DLE 23. That means Diccionario de Lengua Española, or Spanish Language Dictionary. In this slide, you can see the information elements and their marking in the digital text. So they by this marking, this marking will help to access this element when working in the dictionary in digital environment. So here is the example of marking the text. This is the first meaning of the word, head word, agua, or water in English. As a result, we developed the interface. It consists of a horizontal menu, including such tools, statistics, and samples. The second element is a head word list. Third is the text area, which displays formatted text of the dictionary. And the fourth is used to research or to analyze the structure of the dictionary text in HTML format. So with selection tools, we can work with, we can investigate cognate words, including homonymous cognate words, Spanish vocabulary, investigate elements by its origin, and words having suffix or prefixes, and so on. And here there is the example of working with our digital toolkit. So this slide shows the list of the entries with homonym morphemes and parameters selected. Here, selection tools. With selection tools, we made a list of the entries with homonymic words of foreign origin. As for statistics tools, we can calculate the elements in the sample or in the full dictionary. Also with our digital toolkit, we can explore some language regularities. For example, we have selected the head words denoting the action and the action results. Currently, our digital toolkit allows the user to work with head word list and partially with the dictionary text. But in future, the interface will allow working with another information elements in future. Thank you very much. So if you have any questions to the reporter, please, you are welcome to ask.
Yeah, I have one question. May
Yes, yes,
Okay.
you are welcome.
Thank you very much. What is advantage of using dictionary if compared with corpus?
So I think that both instruments are available. Corpus tool with Corpus tool we can, for example, investigate we can investigate word usage in different contexts. It's grammar word variation. Yes, it's good, and using a digital toolkit for dictionaries, we can so with the dictionary in digital environment, we can find out some regularities, system regularities in semantics, word forming, usage, etc. So the dictionary represents a language as a system, and with our tool we can make research. We can research the regularities in the language.
Thank you.
Mm-hmm.
My question is about the ultimate goal of parsing this Spanish dictionary. Maybe I've missed it, but what is your end goal of parsing this dictionary? Thank you.
So the goal of parsing is the first task is to define more precisely the information elements of the dictionary. All information elements with which the user can work with. So he can work and work with individual informational elements and with several. So it's to mark first to mark information elements and to convert the dictionary text into our database. So it's two goals.
But are you going to create a bilingual Spanish-Ukrainian dictionary sometime later?
In prospect, we can. There is a possibility of integrated with another dictionary. So this project doesn't have its end. It's uninterruptible, and you know that there is a trend in integrating linguistic lexicographic resource in global in global environment, in global digital environment. So it means that electronic resource isn't isolated. It has connections to another resources. So, any questions? Thank you very much. Thank you for your questions. And now I'd like to invite our next reporters, Olga Cherednichenko, Olga Kanishcheva, with a report entitled Readability Evaluation for Ukrainian Medicine Corpus, UKRMED. So, you are welcome.
Hello, everybody. I'm Olga Cherednichenko, and I'd like to present the result of our research for today. I share my screen. So we do this work with my colleague Olga Kanishcheva, and the main idea of our research is how we can simplify text in special domain, for example, in medicine domain. And in order to investigate this problem, we research different readability formulas that are familiar for this kind of tasks. And you can see on the slide some common readability formulas that are usually used to evaluate the text according to their complex or simple meaning. So to investigate this problem, we have prepared our own corpus of Ukrainian texts. And I'm sorry, but it is quite difficult to talk when somebody...
Dear guests, please switch off your microphones, please. Dear guests, please switch off the microphones while the reporter is presenting the research. So please, thank you very much. Thank you for your understanding. Please, Olga, you're welcome.
Thank you. I try to continue. As well, we have our own corpus of text in Ukrainian in medical domain. Some characteristics of this corpus you can see on the slide. We prepared our corpus in that way that we have 3 categories of text, like complex texts, moderate like Wikipedia text, and simple like blogs and so on. So features of our statistical features of our corpus you can see on the slide. To evaluate our corpus, we decided to use some different features like phonological, morphological. You can see examples of such kind of features on the slide, as well as synthetic and interstitial features. According to our results, we can underline that all of our texts are quite complex. So we can realize that all of the text we investigated from all categories is quite complex for understanding, and you can see on this slide, for example, visualization of morphological diversity for the text categories, and you can see that all of the text we can say that quite difficult to understanding. So we decide to analyze some readability metrics like Gunning-Fock index and so on. You can see they are on this slide. And after that, we decide to mark up our texts. We asked our students to help us with this task. And we mark up some difficult words, difficult phrases, and difficult sentences. As a result, you can see that complex texts are quite more difficult than moderate or simple. After revising this text and deleted some duplicates, we have some more simple situation, And we can divide it. Moderate text and complex text are similar in the meaning of difficult words. So we research what words were difficult for people. On the slide, you can see top 10 difficult words in our corpus for all categories. And as you can see, it's some specific words from medical domain, or but they are not so difficult in the general meaning. So we can make some conclusion about our result and say that some common readability formulas can't be applied for specific domain, like medicine domain, to evaluate difficulties in such kind of text. So our next step, we think, is to evaluate some ways how we can realize what I'm sorry, what can we will try to understand what kind of words or phrases do difficulties to for this text. Maybe this all for today. I'd like to say thank you for our attention, and I'm ready to answer your question.
Thank you very much for your interesting and international reports. So, dear guests, you're welcome to ask any questions.
I have two questions. May I?
Yes, please.
Okay, thank you. Olga, please tell me, is it possible to create a data set to simplify text without help from student? Is it possible or not?
I think it is possible to create markups of text without student, but we need some volunteers who can mark up, who can do this task.
Okay, I see. And the second question is, what did this markup of complex elements in your corpus give you?
I'm sorry.
Yeah.
Could you please repeat your question?
Okay. Okay. What did the markup of complex elements in your corpus give you?
Better type in chat.
I don't understand. I'm sorry.
Type your question in chat.
Okay.
May I ask now?
Yes, certainly you can ask the
Thank you.
question.
Good afternoon. Thank you for your report. I would like to exact on what basis did you give the features for your program to distribute the levels for your difficult or moderate words. You presented the table of complexity of words, and there were difficult, moderate, and simple words. And what was the basis for your program? The most important features?
Actually, we talk about simple, moderate, and complex, not words, text. We complete our corpus in special way when we complete text like simple text. There are texts like blogs and so on that are very simple to understanding for readers. The moderate text are texts like Wikipedia text level, and the complex text, it's like special medical text like medical protocols and so on. So when we talk about three categories, we talk about text from three categories. And all of these categories were marked up with like difficult words, difficult phrases, and difficult sentences. When our students read this text, they mark up such kind parts of this text, and we analyze what especially makes the text complex.
Okay, thank you.
So we have 8 minutes. So if you have any questions,
I need to answer the question.
Sorry. Okay.
As I understand clearly the question, I try to answer. So we try to understand with this markup what kind of elements of text, like word phrases or sentences, influence on the level of difficulty of this text.
Okay, thank you.
Thank you for your questions.
So, another questions? Okay, we have 7 minutes. So we can start with another report, and if we are interrupted, we shall reconnect using the same link. Okay, so next report is knowledge-based situation awareness process based on ontologies by Yevhen Burov. So you are welcome.
Hello, everybody. My name is Yevhen Burov. I hope you hear me. And today I will present you my the result. I am with Lviv Polytechnic National University, and let me share my screen. And the topic I would like to talk today is knowledge-based situation awareness process based on ontologies. First of all, the growing complexity of our world requires us to make decisions, fast and correct decisions, and evaluate the situation, the environment we are currently in. And this made it is useful to pass this work, or at least partly, to intellectual systems which are using ontologies. The major factors contributing to the complexity, to the real challenge of this problem is the need to combine at the same time perception, recognition, decision making, reasoning, and several processes. And also this should take in consideration the contextual nature of knowledge, because every knowledge is contextual. And also the decisions should be made very fast and real time. So there are several situation awareness process models which represent the understanding how this situation awareness works. The most popular among them is Gdl model, and I will describe this model in my further talk. And also the analysis, the approach of achieving situation awareness using ontologies is not new. However, they typically use quite complex domain ontologies, for example, of upper ontologies, to analyze situations and make decisions. This might be quite cumbersome because ontologies, existing ontologies are very large ontologies, and we may need to use simpler ontologies. In our work, we use a network of simpler dynamically constructed ontologies which are reflecting the context and the situation. So the purpose of our work is to investigate how a different form of ontologies and knowledge models can be used to achieve situation awareness process. And as a result, and as a basis, as one of the main premises of our research, we are using Gdl model. Also, we aim to clarify the definition and establish dependencies between such smaller ontologies such as contextual ontology, situation ontology, task ontology, contextual graphs, and show where they can be used and in situation awareness process. So the main premises of our network is the use of Gdl model of situation aware system, the use of ontologies, and the use of several smaller ontologies. I will structure my further report based on the level or stage of Gdl model. So in the beginning, we have 0 level of Gdl model. In this level, we have an agent, an intellectual agent, which has some internal state, goal, intents, and which observes the environment, the world, using some sensors. Sensors allow to obtain data. Data is read by agent, and this environment, suppose we name this environment in which this agent exists as context of this agent. Context also includes goals, intentions, limitations, and state of the agent itself. In the first level of Gdl model, we obtain data from sensor, and we establish correspondence between those data to values, parameters of attributes values of some conceptual units, usually represented by ontology concepts. Thus, we form the contextual ontology. Contextual ontology is a smaller ontology which describes concepts and relation existing in the world perceived by intellectual agent. And using this contextual ontology, we also build the conceptual model of the environment in which this intellectual agent operates. Interesting fact about the conceptual ontology, a conceptual model, it is changing with flow of time. So when we move from this moment to the next moment, this contextual ontologies and conceptual model change, but only slightly. This is similar to, for example, old movie tape, when adjacent frames were very similar in content, but have only small change in them. And therefore, we can use this contextual ontology as a filter which constrain the size of the number of elements or relations between them to be considered in next level of Gdl model. In second level of Gdl model, we have so-called situation assessment or situation identification. First of all, we need to identify the situation. A situation, as we understand it in our article, is a state of the world which presents some pragmatic interest to agent, not just